Hi everyone, this is Dr. Nak. Today we're going to be learning about functions and notations. Okay, so let's first go with the definitions. Definition number 1. A relation is a set of ordered pairs. Ordered pairs is typically denoted by x comma y in a math class. I'm not sure if you've seen that before, but we're going to be seeing that quite a bit. All right, now definition number 2, domain, or we sometimes call that an input value. But anyways, domain is the first component of ordered pairs. So if I express my ordered pairs in terms of x comma y, then x will be the domain. Now, definition number 3, range, or sometimes we say it's an output, is the second component of the ordered pairs. So again, if you're looking at x comma y, then y will be the range. All right, now let's go with the definition number 4. A function is a relation in which each possible input value has exactly one output, meaning for each x, there is exactly one y value. Okay, so to explain that, let's do some examples. So example 1, given a set of ordered pairs, find the domain and a range. Is the relation define a function? All right, so let's go with part A. Okay, so we're given 3 ordered pairs in a set, 1, 2, negative 1, 2, 3, 7. Now, let's do the easier one first. Let's go with the domain and a range. Okay, so let me just write it as domain. So in this case, remember the domain is the first component of an ordered pairs. So in this case, our domain values are 1, negative 1, and then 3. All right, now let's go with the range. Okay, now the range is the second component of an ordered pairs. Now, let's take a look. For the first ordered pair 1, 2, our range is 2. Now, for the second ordered pair, we have negative 1, 2. So, guess what? We have another range value to be 2. So, if that happens, please do not write 2 twice. Okay? All right, so then the last ordered pair is 3, 7, so the range will be 7. Okay, so again, your range is not going to be 2, 2, 7. It's just going to be 2, 7. Now let's determine whether this relation defines a function or not. Let me draw a picture real quick. All right, so what I did was I just drew the picture of the domain and a range. So again, where our domain is 1, negative 1, and 3. And then our range is 2, 7. Okay, so now I'm going to make some arrow to define a relation. So when the domain value is 1, well, I should say when x is 1, your y value is going to be 2. All right, and then when x is negative 1, your y value is also going to be 2. All right, and then when x is 3, your y value is going to be 7. So what do you think? Do you think this relation becomes a function or not? Now the answer is yes, this relation defines a function because look at it. For each value of x, there is exactly one y value. It does not matter whether 1 goes to 2 and negative 1 goes to 2 because x values are different. So in this case, yes, this relation defines a function. So I'm just going to write it as yes. It's a function. All right, now let's do the same thing. Example B. So what I pretty much did was I kind of swapped the ordering of the domain and the range here from example A. So let me just write down. Let's first go with the domain. And then we'll do the range next. All right, so the domain in this case is 2. Again, we do not repeat another 2. And then 7. And then our range is the y value, the second component. So you're going to have 1, negative 1, and 3. Okay, so let me do the same thing. Let me draw a picture real quick. Okay, so now I'm going to do the same thing as what we did in example A. So let's define this by using an arrow. So when x is 2, your y value is 1. All right, now second ordered pair, when this is telling you that when x is 2, y is negative 1, right? And then when x is 7, then our y value is going to be 3. So this is the relationship that's going on right now. Not relationship, relation, sorry. Okay, so now let's see. Is this going to be a function or not? I say it is a no because of this reason. Now remember that in order to be a function, for each x, there better be exactly one y value. Okay, so let's take a look at 2. When x is 2, where's it going to go? 2 can go to 1 or -1. So which means that 2, which is the value of x, there are 2 different y values. So in this case, this relation does not define a function. So I'm going to write it as no, not a function. Let's talk about function notation. It says that the notation y equals f of x, that's how you read it, defines a function named f. This is read as y is a function of f, where x is the input value and then the y is the output value. So basically what's happening is this. Our y is going to be the output value. Think of f as being like a rule, okay? And then x is the input value, and sometimes that's called the argument of our function f. So you're like, well, what the heck is the rule, right? So let me just give you one example in non-math way, I should say. Okay, so let me just draw a picture real quick. Okay, so what I just drew is pretend that's a function f, and then our input value is x, right? So here is my x, and then it's gonna go into a machine. You can think of f being a machine or something like that, and the output value is going to be the y value. Okay, so suppose the rule is that whatever that we're gonna input, the output is gonna be, we just add 1 to the inputting value. Oh my gosh, did that even make sense? Okay, so let me just try to re-explain it again. So here's the picture of, inputting value, and then f being the rule, and then the output value is the y. Okay, so I'm going to assign the rule for f as add 1 to input value. So let me just write that. So the rule is add 1 to, that's a 1, to input value. Okay, so suppose that's the rule. Okay, so now let's do this more mathematically. So I'm going to choose my x value to be 3. Okay, now I'm going to input the 3 into our function f. So what's the rule? Well, the rule is that I have to add 1 to our inputting value, and that's going to be the output value. So in this case, what's going to be the output? Well, in this case, output is going to be 4 because rule said that add 1 to the inputting value. So your answer is going to be 4. Okay, so let's write that in mathematical notation. So what we just did was this. We computed that f of 3 equals to 4, right? Where our f of x, the rule is what? Whatever the inputting value, you just add 1 to it. So that's how you would translate what just happened in terms of a mathematical notations. We'll come back to this a little bit later on. But for now, let's play a different game. So let's take a look at example 2. It says that to determine whether the relation represents y as a function of x. Now, let's recall the definition. So the relation becomes a function if for each x, there is exactly one y value. Keep that in mind. Let's first go with example 2a, y equals x cubed, or x to the third power. Now, there are many ways that you can determine whether y equals x cubed is going to be a function or not, But for now, let's make a XY chart, meaning this. I'm just going to bust out this chart, X and a Y, and I'm going to start randomly plugging in the value of X. Okay, so let's go with the negative side. So you're going to have -2, -1, 0, 1, 2. I'm just randomly choosing the X values. All right, so now Y equals X cubed. So when X is -2, then your Y value is going to be -2 to the third power, which is -2 times -2 times -2. So your answer would be -2 times 2 is 4. 4 times 2 is 8. So it's going to be -8. All right. And then when X is -1, your Y value is going to be -1 cubed. So in this case, you're going to have a -1. And when X is 0, your Y is going to be 0 cubed, so it's going to go to 0. And when X is 1, you're going to have Y equals 1 cubed, which is 1. And when X is 2, your Y value is going to be 2 cubed, so this is going to be 8. So if I express this in terms of an ordered pair, we have this situation going on. -2, -8, -1, -1, 0, 0, 1, 1, and then 2, 8. Okay, so does each X, for every value of X, is there exactly one Y value? I believe so, because look, when X is -2, there is only one Y value, which is -8. When X is -1, yes, there's exactly only one Y value, which is -1. When X is 0, your Y value is also going to be 0. So when X is 0, this guy has exactly one Y value. So in this case, yes, Y equals X cubed defined as a function of X. Okay, so let me write down the answer. So I'm just going to write it as yes, it is a function. Okay. So let's take a graph by looking at the graph of Y equals X cubed. So the picture that you see right there, I'm not sure, can you see this okay? My lighting in this room was so bad. So Y equals X cubed looks something like this. Oh my gosh. Now we just discovered that Y equals X cubed is a function. So what does it mean? How do we determine that? Well, we argued our way through that. For each X values, there is exactly one Y value, right? So I don't know if you can see this. Let me just blow it up a little bit. So this value is going to be 1. So this is 2, -1, and this is -2. Okay, so now let's take a look. When X is 1, your Y value is going to be here. Correct? So your Y value is going to be here. So this point right here is 1, 1. And then when X is 2, so let me just write that. When X is 2, your Y value is at the very tip of the graph in this case. So here, so in this case, when X is 2, well, there's exactly one Y value, which in this case, it looks like, what is it? When X is 2, it's supposed to go to 8. Okay, so pretend that's 8. Okay, so, and then let's do the same thing. When X is -1, right, where's my corresponding Y value? Well, what your Y value is going to be here. Not our Y value is going to be here, right? So when X is -1, there's exactly one Y value. And similarly for when X is -2, right? Where's the Y value? Well, Y value is going to be down here somewhere. So notice that again, when X is -2, then there is exactly one Y value, which is going to be, what was that? -8 in this case. Okay, let's do another example. So part B, we're given 3x squared plus y equals to 14. Now, the easiest way to determine whether a given equation is a function or not, solve for y. Okay, so how do we solve for y? We subtract 3x squared from both sides, right? So then our y is -3x squared plus 14, or same thing as 14 minus 3x squared. Okay, So please note that the graph of 3x squared plus y equals to 14 and y equals negative 3x squared plus 14 are identical. They're the same graph. They better be. All right, but anyways, so let's do the same thing as what we did earlier. So I'm going to make myself a chart, xy. And I'm just going to put some random values. I'm just going to start from negative 2, negative 1, 0, 1, 2. Doesn't matter, whatever value, x value that you like, just start from there. Okay, now, so corresponding y value is going to be, let's compute. So when x is negative 2, you're going to have negative 3 times negative 2 squared plus 14. So that's same thing as negative 3 times negative 2 whole quantity squared is positive 4, and then plus 14. So in this case, what do we get? Negative 12 plus 14, so this is going to give us 2. So in terms of an ordered pair, I can write this as negative 2, comma 2. All right, now let's go with when x is negative 1. So we're going to have negative 3 times negative 1 whole quantity squared plus 14. So this is negative 3 times positive 1 plus 14, which is negative 3 plus 14. So what is that? 11. So what do we got? We have negative 1 comma 11. Now when x is 0, you're going to have negative 3 times 0 squared plus 14, which is just 0 plus 14, which is going to be 14. So as an ordered pair, we can write this as 0 comma 14. All right, 2 more. Let's go. So when x is 1, then you're going to have negative 3 times 1 squared plus 14. So that's same thing as negative 3 times 1 plus 14. So that's, what is that? Negative 3 plus 14. So again, this is going to be 11. So here, what we're going to get is 1 comma 11. Okay, and then when x is 2. So you're going to have negative 3 times 2 squared plus 14. So that's negative 3 times 4 plus 14. So that's negative 12 plus 14, which is 2. So it looks like we're going to have 2 comma 2. Okay, so if you still are not comfortable to determine whether this relation defines a function or not, you could do the same thing as what we did before. So here's the good old picture of the domain and then the range. All right, now let's define this relation. When x is negative 2, it's going to go to 2. Negative 1 goes to 11. When x is 0, y is 14. When x is 1, your y is 11, and 2 goes to 2. So notice that for each value of x, there is exactly one y value. Okay, so in this case, yes, this becomes a function. So I'm going to write it as, function. Let me just go like this. Function. Okay, so now let's take a look at it graphically. Alrighty, so this is the graph of y equals negative 3x squared plus 14, or the same thing as 3x squared plus y equals to 14. It's exactly the same graph. Oh, by the way, this shape of the graph is called a parabola. We're going to have to know that anyways later on, so I'm just going to write it out. Parabola. Okay, anyways, okay, so now let's just analyze the graph. So this point is going to be x equals to 1, and then here is x equals to negative 1. Okay, let's play the same game. Okay, when x is 2, how many y values do we have? There's only one y value, which is, let me just jot it down at this point right here. So notice that again, when x is 2, there is exactly one y value. All right, now let's go with when x equals to 1. When x equals to 1, where's the corresponding y value? Well, corresponding y value is here, correct? So when x is 1, there's exactly one y value. You could do the same thing for the 0. When x is 0, where's the corresponding y value? Y value is here. All right, so when x is 0, you're only given one y value, right? So this tells you that your given graph is a function. Okay, so let's take a look at another example. So part C, we're given 2x plus y squared equals to 6. So again, if I were you, I will solve for y. Okay, so in order for us to solve for y, you need to subtract 2x from both sides. Then you're going to have y squared equals negative 2x and then plus 6. All right, but I need to solve for y. I don't want y squared. So what we need to do is we need to take the square root on both sides. But be careful. When you take the square root on y squared, on the right hand side, you're going to have a plus or minus. Okay, so if I take the square root, let me just go square root it. On the next step, you better have y equals plus or minus the square root of negative 2x plus 6. So this means that your y is positive square root of negative 2x plus 6, and y is negative square root of negative 2x plus 6. Uh-oh. Do you notice what's going to happen here? If you don't see it right away, let's do the same thing as what we did before. Okay, so we're going to have an x and then the y chart. All right, so let's input, let me just go x. Remember, there are two y functions, right? So you're going to have x here and then our y. So this part is negative square root of negative 2x plus 6. And this one is y equals positive square root of 2x plus 6. Okay, so let me just pick fewer numbers to compute. So let me go with when x is negative 1, 0, 1. All right, and then we're going to do the same thing, negative 1, 0, 1. Okay, so in this case, let's first start out with the y equals positive square root of negative 2x plus 6. So when x is negative 1, your y value is going to be negative 2 times negative 1 plus 6. Oh no, I'm running out of room. So in this case, you're going to have a square root of, what is that? 2 plus 6. So in this case, you're going to have square root of 8. Okay, I'm just going to leave it like that. All right, now when y is 0, you're going to have negative 2 times 0 and then plus 6. So in this case, you're going to have square root of 6. And when x is 1, your y is going to be negative 2 times 1 plus 6. So in this case, this is going to be square root of 4. It's going to be 2. All right, so let me just write this out as an ordered pair. So when x is negative 1, y is square root of 8. When x is 0, it is, what is the y value? Square root of 6, and then 1 comma 2. That's what we get. Okay, and we also have to take care of the negative side. Okay, so let's do it. So when x is negative 1, your y is going to be negative square root of negative 2 times negative 1 plus 6. All right, so in this case, what do we get? We're going to have a negative square root of 2 plus 6, which is going to be negative square root of 8. Now, when x is 0, you're going to have negative square root of negative 2 times 0 plus 6. So in this case, you're going to have negative square root of 6. And when x is 1, you're going to have negative square root of negative 2 times 1 plus 6. So here you're going to have negative square root of 4, which is negative 2. So you have negative 1 comma negative square root of 8, 0 comma negative root 6, and then 1 comma negative 2. Now you have to consider both all the ordered pairs as your answer. Okay, so let's see what's going on here. Let's take a look at when x is negative 1. When x is negative 1, notice that you have two different y values. One's positive square root of 8 and then one's negative square root of 8. So that violates the rule of the expression being a function. Okay, so similarly here, when x is 0, right, because these are the domain values, look at the y values. They have two different y values, right? One is root 6 and then another one is negative root 6. So in this case, this equation is not a function. So I'm just going to put not function. Okay, so I'm just going to leave it as that. And now let's look at the graph of 2x plus y squared equals to 6. Okay, so this is the graph of, what was the equation again? 2x plus y squared equals to 6, or y equals to plus or minus the square root of negative 2x plus 6. Okay, I don't know if you can see that. Sorry, that's a 6 that I just wrote at the very end. Okay, so now let's play the same game. So this is going to be 2, so this is 1, negative 1, and this point's negative 2. All right, so now let's take a look. When x is negative 2, where's your corresponding y value? Well, one of the y value is here, but there's another one. Another y value is over here, right? Okay, so for each x, there are 2 y values. So that's why this is no longer a function. And same thing for when x equals to 1, right? So when x equals to 1, where's the corresponding y value? Well, pretend that was a straight line. Okay, so your y value is here, and then there's another corresponding y value when x is 1, which is this point. Okay, so again, therefore, this is no longer a function. So I'm going to write it as, this is not a function because each x, there are 2 y values. Okay, so what I did here was I just put down the graphs of examples A, B, C. Okay, so let's do a little recap. Okay, so when y equals x cubed, we determined that we claimed that this is going to be a function. So we already know that this is a function. And then for the y equals negative 3x squared plus 14, we also determined that it is a function. And the last one is not a function. That was our conclusion. Okay, so now when, let's do the same thing here. So when x is 1, there is exactly 1 y value. When x is 2, there is exactly 1 y value, correct? Same thing here. For each x, is there only exactly 1 y value? Yes, because let's take a look. When x is 1, where is the y value? Y value is here. There is no other value for y when x is 1, right? Same thing, when x is 0, there is exactly 1 y value, nothing else. Okay, so notice that for these two examples that we went over, if I draw a vertical line anywhere on the graph, it only intersects the graph at one point only. Same thing here. So here's my vertical line. I could draw a vertical line anywhere on this graph, and the line would intersect the graph at only one point. All right, now let's take a look at something that was not a function, right? Because for each x, there were 2 y values, correct? So in this case, let's take a look at when x is 1. Well, we determined that it has 2 y values, which is here. And then, so 2, and then at negative 2. So when x is 1, we have 2 different y values. So that violates the rule of y being a function. So what is the difference? Notice that if I draw a vertical line, just like what we did before, right, for the 2 previous example, notice that it intersects the graph at more than one point. So guess what? When that happens, your y is no longer a function. To summarize it all, here is the theorem, vertical line test. It says that if we can draw any vertical line that intersects the graph more than once, then the graph does not define a function. That's exactly what happened with our 3 examples. All right, so now let's play a different game. Okay, example 3. Evaluate the function f at the indicated values, f evaluated at negative 3, f evaluated at negative a, negative f of a, and then f of a plus h. We'll do a few examples on this one. Okay, so let's take a look at example 3a. Let's look at f of x equals 2x plus 5. Let's do this in order. So first we're going to evaluate f of negative 3, and then f of negative a, and so forth. All right, so let's first go with f of negative 3. So if I go f, and then our inputting value is negative 3. Right, so let me just change the color, negative 3. So that means that you're going to have to replace the x with negative 3. So this is same thing as 2 times negative 3 and then plus 5. Okay, so in this case, what do we get? Negative 6 plus 5, so which is negative 1. All right, so that's going to be the answer for f of negative 3, or f evaluated at negative 3. All right, now let's go with f of negative a. All right, so we're going to do the same thing. All you have to do is wherever you see the x, you just replace it with what's in the parentheses. So here you're going to have 2 times negative a and then plus 5. Okay, so do not panic just because you don't see a number. Instead, you see a letter. Okay, so then here what we're going to get is negative 2a and then plus 5. And you cannot simplify this any further. So this is going to be our final answer. All right, so now let's go with negative f of a. Okay, so we got negative f of a, but don't forget this negative as well. Okay, so this is telling you that first you need to multiply the whole function f of x by a negative, and then don't forget the bracket or parentheses, either one's okay. So now what we need to do is you just replace our a with x. So here what we're going to get is 2 times the a and then plus 5. I should have put a parentheses. I don't know why I put a bracket. Means the same thing. Okay, so which gives us, don't forget that negative on the front of the bracket. So you're going to have negative 2a plus 5. One more step, distribute the negative sign to get negative 2a and then minus 5. And you cannot simplify this anymore, so that's going to be our answer. All right, how you guys all doing? Hopefully you're catching on. It takes a practice, you know. When I was a student, I just did not understand how to compute f at a certain value, especially when it was no longer a numerical value. So I feel your pain. Okay, but let's do the last one. F of a plus h. We got this. So ready? F of a plus h. Again, do not panic. Okay, pretend a plus h is just one numerical value or something. Okay, so what we need to do is we're going to replace our x with the whole entire a plus h. I don't know why I put the right parentheses in blue, but here we go. All right, ready? So you're going to have f of x equals 2x plus 5. So what we need to do is we're going to have to replace that x with a plus h in the parentheses, don't forget, because a plus h is one quantity, and then you just add 5 to that. Okay, so then distributing the 2 in, you're going to have 2a plus the 2h and then plus 5. Since they're not like terms, this is as far as we can get. So this is our answer. All right, so now let's do another one. F of x equals negative 5x squared plus 2x minus 1. Okay, so let's try this one. Okay, be confident, we got this. All right, so let's first go with f of negative 3. And you know what? Before I begin, let me just color x, because these are the places that we're going to be replacing the numerical value or variable with. Okay, so ready? So let's go with f of negative 3. So in this case, we're going to have negative 5 times, again, why did I put it in blue here? Doesn't really matter. Okay, so ready? So you got a negative 5 times negative 3, and then you square that, and then plus 2 times negative 3, and then you got yourself a minus 1. So far, so good? All right, please tell me if I made a mistake somewhere. I make mistakes all the time. Okay, so let's just go here. So now you got negative 5 times negative 3 whole quantity squared is positive 9. And then you're going to have minus 6 and then minus 1. So what is that? Negative 45 minus 6 minus 1. Remember, when you do this, you have to add and subtract from the left to right, right? So first, what I'm going to do is I'm going to go negative 45 minus 6, which is negative 51, and then minus 1, so which is going to give us negative 52. So I'm going to box that for the answer. All right. Now let's go with f of negative a. You know what? Why don't you pause the video and try to evaluate f of negative a on your own. So feel free to pause the video and try it. Okay, so I'm going to pretend that you tried it. So let's go. F of negative a. Okay, so that's same thing as negative 5 times negative a squared plus 2 times negative a, and then minus 1. Okay, so here you're going to have negative 5 times, you're going to have negative a whole quantity squared is positive a squared, and then minus 2a, and then minus 1. Okay, now since they're not like terms, we cannot simplify this any further, so I'm going to box this for our answer. All right, how you all doing? Okay, so next, negative f of a. So again, why don't we pause the video for a little bit and try that on your own. Okay, so let's continue on. So let's compute negative f of a. Okay, so I did not color code it this time, so let's see if we can do it. Okay, so first you better have negative at the very front of it, and then make sure to put a bracket because you're about to compute f of a. Okay, so f of a is going to be negative 5 times the a squared plus 2a and then minus 1. So take one step at a time. So this is negative. So you're going to have negative 5 a squared. Please note that that exponent 2 is only attached on the a, not on the negative 5. So leave the negative 5 alone. All right, and then you're going to have a plus 2a minus 1. Now distribute the minus sign to each term. So our answer is going to look like positive 5a squared minus 2a and then plus 1. And that's going to be the answer. How did you do on this one? Hopefully you're getting it. And let's do the last one. The last one is the f of a plus h. Okay, so again, feel free to pause the video if you want to try this on your own. But I'm going to start. Okay, so let's go. So this is same thing as negative 5 times a plus h squared plus 2 times a plus h and then minus 1. Now be careful here. All right, so I'm going to write this in red because this is common mistake that a lot of students make in this class. Please note that a plus h squared does not equal to a squared plus the h squared, by the way. Okay, because a plus h squared means that you multiply a plus h twice. So this means this is a plus h times another a plus h. So you have to FOIL. All right. Okay, so now this is same thing as negative 5 times a plus h times a plus h. And then you know what? Let me distribute the 2 to each term already. So you're going to have plus 2a plus 2h and then minus 1. All right, let's keep going. So this is negative 5 times. All right, so now what I'm going to do is I'm going to FOIL this. Okay, then if I do that, then I'm gonna have a squared plus AH plus HA plus H squared. And then let me just jot down plus 2A plus 2H and then minus 1. So this is negative 5 times A squared plus AH and then HA. They're the same thing. So you're going to have 2 copies of AH and then plus the H squared. And then jot down plus 2A plus 2H and then minus 1. Now let's distribute the negative 5, oh my gosh, to each term. Okay, so then you're going to have negative 5A squared minus 10AH minus 5H squared plus 2A plus 2H minus 1. All right, so now do we have any like terms here? You got a squared, AH, H squared, AH, and a constant. Nope. So guess what? This long thing is going to be our answer. How did you guys do on this one? Hopefully you're getting it. And do you want to do another one just for heck of it? You know what? Why not? Let's do another one. Okay, so try to make it look something just a little bit different. So let's go with part C. So I'm going to make it up. So our f of x is going to be maybe 5x plus 1 over 2x and then minus 3. Why not? All right. So let's first compute, what was the first one? Was it f of negative 3? All right, so let's first go with f of negative 3. Do not panic just because you see a fraction here. It's called a rational expression, by the way, but you're going to have 5 times negative 3 plus 1 over 2 times negative 3 minus 3. So you're going to have negative 15 plus 1 over negative 6 minus 3. Am I doing this right? Yep. So then here you're going to have negative 14 all over, what is that? Negative 9. Okay, please, negative over negative makes it into a positive. So this is a 14 over 9, which is same thing as 1 and, what is that? So let's go. 14 divided by 9. It goes in once. So you got a 9. Remainder is 5. So it's 1 and 5 over 9. So that's going to be our answer. All right. So now let's go with, what was the next one? F of negative a. So let's go with f of negative a. Easy peasy, we got this. So ready? So you're going to have 5 times negative a plus 1 over 2 times negative a minus 3. So what do we get? You get negative 5a plus 1 all over negative 2a minus 3. All right, so you cannot simplify this anymore. So this is the answer. Oh my gosh. Okay, this is illegal math right here. I know it's so tempting. You see a's, right? So you so want to cancel that out. But that is an illegal maneuver. When is the only time you can cancel the a is if every single term is being multiplied. Okay, the problem is that negative 5 times a, that's being multiplied, so it's negative 2 times a. But the problem is on the top you have a plus 1, on the bottom you have a minus 3. So these are not a multiplication. Okay, so that's the reason why you cannot cancel the a's. All right, so keep that in mind. So this is going to be the answer. Now, what's next? Negative f of a. So negative f of a. Okay, so bust out the negative sign to begin with. All right, and then put a bracket. Now we're going to compute f of a. Okay, so in this case, you're going to have 5a plus 1 over 2a minus 3. Okay, so please note that if you have a negative sign outside of the fraction, that negative sign only distributes to either the numerator or the denominator. It does not distribute to both top and a bottom. Okay, so what I'm going to do is this. I'm going to distribute the negative sign on the top. Okay, and then leave the bottom alone. All right, so in this case, you're going to have negative 5a minus 1 all over 2a minus 3. Okay, so I'm just going to box that for the answer. Now, if you wanted to toss that negative sign on the bottom, your equivalent answer would be 5a plus 1, and then all over negative 2a plus 3. They're all equivalent. It all depends on where you want to toss that negative sign. Okay? All right, now I just rewrote the function here. So now let's compute f of a plus h. Okay, so here what we're going to get is 5 times a plus h plus 1 all over 2 times a plus h and then minus 3. All right, simplify. Again, please do not cancel out the a plus h's because this here's the addition and here's the subtraction. They're not being all multiplied together. Okay, so we're just going to have to deal with the way it is. So you're going to have 5a plus 5h plus 1 all over 2a plus 2h minus 3. And that's pretty much as far as we can go. If you're following up to this point, great job. You're doing great. Okay, so let's step away from computing f, evaluated a plus h, and so forth, and then let's just shift it a little bit. So let's talk about something a little bit different. So another definition is this. We say that the f is one-to-one function if for every y there is exactly one x value. Now, please do not get confused with f being a function. F being a function was the other way around, right? For every x, there is exactly one y value. But one-to-one, you kind of have to swap the role of x and a y. Let's do example number 4. Which of the following sets of values represent a one-to-one function? All right, so again, remember that function is one-to-one if for every y, there is exactly one x value. Okay, so let's go with A. Okay, so here are all the y values. Here are all the x values, right? Now, for each y value, is there exactly one x value? I believe so, because when y is negative 5, that guy only goes to negative 4. When y is negative 2, that guy goes to negative 2 only, and so forth. So in this case, yes, this is a one-to-one function. So I'm going to write it as one-to-one. All right, so let me just box that. Okay, so now let's take a look at part B. The question is, for each y value, which are 12, 6, and a 5, is there exactly one x value? Okay, so let's go with 12. When y is 12, what are the corresponding x values? Well, you got negative 6. When y is 12, x is negative 6. When y is 12, y can also be 6. Okay, so that means what? Our y value has 2 different x values. So therefore, this is no longer a one-to-one function. Okay, so I'm just going to write it as not one-to-one, because 12 goes to negative 6 and a 6. All right, so let me just box that. And then also look at the y value when y is 6. When y is 6, has something similar happens. 6 is going to go to, 6 came from, I should say, negative 3 and 3. So when y is 6, there are 2 different x values. So that tells you that it's not a one-to-one. Okay, so let me box that. Okay, now let's go with part C. So why don't you pause the video and try to determine whether this is a one-to-one function or not. All right, so what's your conclusion? I claim that this is not one-to-one. Why? Well, all you need is one failure, then everything crumbles down. So let's take a look at when y is negative 3. What are the corresponding x values when y is negative 3? Well, negative 4 and negative 2. So that violates the rule of f being a one-to-one function. So therefore, the answer is this is not one-to-one. All right, so here comes the horizontal line test. So this is another way to determine whether a given function is a one-to-one function or not. Okay, so let's just read the horizontal line test. It says that f is a one-to-one function if any horizontal line intersects the graph at only one point. Let's do an example. Example 5 is the graph shown a one-to-one function. So what I did was I just busted out the same graph that we talked about when we were learning about the vertical line test. Now remember that A and B, we determined that those are functions, right? So let me just write it as function. We already discovered that. But the last one was not a function. All right, so keep that in mind. So let's go with part A. Okay, so is this a one-to-one function? So which means, does it pass the horizontal line test? So if I draw a horizontal line anywhere on the graph, does that horizontal line intersects the graph only at one point? Answer is yes. So in this case, this is a one-to-one function. So I'm going to write it as 1, 2, 1. All right, now let's go with part B. Well, it was a function because it passed the vertical line test. Now, is it one-to-one? Meaning, does it pass the horizontal line test? What do you think? Well, let's just chop this graph off here. I'm just going to draw the horizontal line here. Then notice that the horizontal line intersects that graph at 2 points. So in this case, this is not a one-to-one function, but it is still a function, okay, but just not one-to-one. All right, now let's talk about part C. Now, since we discovered that it fails the vertical line test, which tells us that this is not a function. So if it's not a function, then there is no way that it could be one-to-one function because it's not a function to begin with. Okay, so in this case, this is not a function, so we cannot even talk about one-to-oneness. So I'm just going to write it as not a function. That implies that can't even talk about f being one-to-one. So how should I write that? Not a function. No way in heck that this is one-to-one. I just write one-to-one as 1-1. All right. You know what? Let's take a look at another one. Part D. Okay, so all I did was I just took the top half of this graph. Okay, so that's what we have here. All right. So first of all, is this a function or not? How do you determine whether the given graph is a function? Does it pass the vertical line test? Okay, let's check it. Everywhere you draw the vertical line, that line intersects the graph only at one point. So in this case, this is a function. All right, now the question is it one-to-one? Meaning, does it pass the horizontal line test? Well, what do you think? I think it does pass the horizontal line test because everywhere I'm going to draw the horizontal line, that line intersects the graph at only once. So therefore, this is a function. Furthermore, it is a one-to-one function. So I'm just going to write it as 1, 2, 1. Okay, for our last example, let's see if we still have energy or not. Example 6, let f of x be 5 minus x squared. Find f of a plus h minus f of a, whole thing divided by h. Now, those of you who's moving on to calculus, which is most of you, I hope. Now, this expression has a very, very important role in calculus. Now, this expression is called the difference quotient. Anyways, let's do this problem. All right, so first, what we need to do is to compute f of a plus h. Then let's compute f of a. Then we're going to subtract f of a from f of a plus h. Okay, so ready? So we have f of a plus h. Let's do it one piece at a time. So this is 5 minus a plus h squared, which is same thing as 5 minus a plus h times by a plus h. So this is 5 minus, don't forget the parentheses or bracket when you FOIL. So you're going to have a squared plus ah plus ha. So that's same thing as 2ah plus the h squared. Okay, so this is 5. I'm going to distribute the minus sign to each term in the bracket. So my minus a squared minus 2ah minus the h squared. All right, so this is one piece. This is our f of a plus h. All right, now let's compute f of a. Okay, so f of a is just going to be, what is it? 5 minus just a squared. Oh, that was cute. Okay, so this is our f of a. All right, nothing to do for the denominator, so now let's compute. So therefore, oh, by the way, this 3 dots on the triangle means therefore in a math class. Okay, so therefore, f of a plus h minus the f of a, whole thing divided by h. So this is going to be 5 minus a squared minus 2ah minus the h squared. So remember, that is our f of a plus h, and then minus f of a, which is just going to be 5 minus a squared. And then don't forget the denominator, whole thing divided by h. All right, so now let's distribute this minus sign to each term here. Okay, then what do we get? We have 5 minus a squared minus 2ah minus the h squared minus 5 plus a squared, whole thing dividing by h. So far so good. All right, now let's simplify as much as we can. So first of all, what can we cancel? Yep, we can cancel the a squares. That's going to disappear. What else? 5, oops, excuse me. 5 and a 5 cancels each other, right? Here's 5 and then minus the 5. So who's left over here? It looks like we only have minus 2ah minus the h squared, whole thing dividing by h. Now, we have to go one more step because we have to simplify this expression all the way. So notice that I can factor the h out from the numerator. So I'm going to do that. So if I factor the h out, then you're going to have h parentheses minus 2a minus h, whole thing dividing by h. Now notice that our expression on the numerator is being multiplied. You have a h times by this one chunk of a number dividing by h. So in this case, yes, we can cancel out the h's. By the way, this always happens at the very, very last step. When you compute the difference quotient at the very, very end, you're going to have to factor the h out from the numerator. So you should no longer see the h on the bottom. If you still see the h on the bottom, that means you did something wrong. All right, so with that said, our final answer is minus 2a and then minus h. And this is going to be our answer. So this is the difference quotient of f of x equals 5 minus x squared. All right, I am done with this section. So if you have any questions at all, please let me know. You know where to reach me. And great job, everyone. If you hung out till example 6, you are a champ. That's all I have to say. But anyways, until next time, bye.